Crossing. Today we have with us Prashant Andhale, who is a digital transformation consultant at Yokogawa Electric. He has more than 14 years of experience in industrial automation, particular in advanced solutions area. Before joining Yokogawa, Mr. Andhale worked in Honeywell and Matrikon. And today we will be having a discussion with him on digital transformations in manufacturing and the opportunities and challenges involved. Welcome to the Zebra Crossing.
Yeah. Thanks, Janhvi, for giving me opportunity to explain this niche area. Yeah.
It's a pleasure to have you with us. First of all, can you tell us a little bit about yourself, your background, and your profession as well?
Yeah. So basically, I graduated in information technology from Pune Institute of Technology, Pune, and then I'm more working in like customer facing, knowing the customer challenges and give them solutions in the area of particularly in operations management.
All right. Now, your work is related to manufacturing. So, how is life when you're working with manufacturing softwares?
So, basically, manufacturing is what? Converting all like raw materials to some finished good using like some tools, labors, or some processes. So basically in manufacturing, you can see different types of manufacturing, like continuous manufacturing, batch manufacturing, discrete manufacturing, additive manufacturing, and nowadays they are considering like 3D printing is another type of manufacturing. So basically two manufacturing types, continuous manufacturing and batch manufacturing, are the important I would like to emphasize. So basically in continuous manufacturing, same kind of products are getting manufactured through some product like production lines or plants we call, and these products these plants basically running 24/7 to produce that particular items or finished goods. And in batch manufacturing, example of batch manufacturing, we can say like pharmaceuticals manufacture the tablets, for example. So in that basically same infrastructure of the plant, like same equipments used to manufacture different kinds of specs and items, because raw materials will be different but process of manufacturing more or less will be same. And in this manufacturing, basically they follow some recipe or standard operating procedure we call SOP to manufacture the item. So different manufacturing plants, like simply different parts of vehicle or automobile, then assembling those parts to form the car or different vehicles, or manufacturing of specialty chemicals. Then crude oil refining is one of the manufacturing, or pharmaceuticals. Even power plants, where like thermal power plants or renewable solar wind power plants, they are kind of manufacturing where they are producing the power or electricity and then transferring that to the grids.
Wow, I had no idea there were so many different types of manufacturing processes. Can you give us an example of one of them?
Yeah, so in today's discussion, maybe we will more contextualize in terms of the crude oil refining actually. So if you see crude, how it is produced, it comes from the crude wells underneath, under the ground. So that portion of the crude business is called as upstream, where exploration of the crude from the underground oil wells, then that is moved to like tanks or tank farms through ships or pipelines or tankers. So that is upstream portion. And then when it comes to tanks, and then it went for refining or producing different products and byproducts out of that crude, that is basically downstream operations. So when there is like in tank farm, these all crude oil comes, then it goes to through different chemical processes basically. So if you see the refinery, there it is like network of pipelines, and there are so many equipments are available. So this particular crude oil goes through those pipelines to different units, and there is like some chemical processing, like CDU unit is there, crude distillation unit, in which this oil or raw material, which is crude oil, is heated at very high temperature, and then it is separated into like gasoline, diesels, jet fuels, and some other byproducts basically.
Okay.
Then for this you need different utilities actually, like boilers to or heaters or condensers, heat exchangers in this complex process. So that is the utility we considered in the refining manufacturing. And if you see this particular refinery, at every step there are different kinds of meters are installed, because at the end of the day we need to measure what is happening. And there is like separate control room in the refinery where from where like operators or operations manager are controlling the plant. Mostly that plant is running in automatic way or autonomous operations, and in future we are planning for that autonomy, like completely it will be automatically handled. So if you see in the plant, there are like level meters, temperature sensors, then there are like valve on off things we can do remotely, or there are like pumps involved, or there are like different boilers, and also it's mix of different precious assets and different sensors and actuators to measure the performance of those assets and operations basically.
Okay.
Yeah.
So there's so many sensors and valves, tanks, so much different equipment involved in this. How is all this taken care of so that the whole process is very flowy?
Yeah. So basically there are in this manufacturing operations there are five pillars of that operations basically. So first one is quite important, health and safety. So people working there should be safe. In the refinery or any manufacturing, there will be like different gases in that, poisonous gases or different liquids which are boiled to very high temperature, and that if something happens like burst, then it will be the threat for human being. In past, I have seen like in India, Bhopal gas tragedy was happened. So many people died due to some leakage of the gas, or in worldwide, like in many refineries, some blast happened and people lost their life. So health and safety of the people is very important in the refining, and for that there are like safety systems are in place to identify the anomaly, and then like it will be alerted through like different kinds of alerting. That is like health and safety. Then productivity. So like any business run for productions and profitability, and they always strive to produce more with less. So you should not like when we are running any manufacturing operations, the minimal waste of like your utilities like water, electricity or steam, minimum wastage of your raw materials is quite important. And like emissions should be also minimum to have better productivity actually. Then it comes to quality. So if you are producing anything, your customer is asking some specs for that finished good, so that should come into the quality which they have demanded. If it is not up to the quality, then that will be again waste, like that finished good will be waste. So that quality is another very important aspects. And then it comes to reliability actually. So I mentioned like there are different equipments like boilers, heat exchangers, which are very much like cost having cost sensitive. They like come up with millions of dollars investment in the plant. So if you ask me, like if out of the 100% investment in the plant, 10% is just digital transformation, but 90% is like building and establishing the plant. So that is quite big in like $1 billion investment. So health of those equipments is one of the priority. If some equipments down, like boiler down or like some pump down, again there are like redundant things also, like for one pump there is redundant, if this fails another can work actually. But if they are not taken care well, then if that refinery or manufacturing plant is down, then it may cost billions of dollar production loss. So reliability of the equipment is one of the important aspect in this overall manufacturing, and for that we come up with like asset performance monitoring. So we continuously monitor that asset, and we can like predict the failure of that asset well before it fails. And
Okay.
then at the end it comes like sustainability. So sustainability nowadays is very important aspect, where we need to pass this mother earth well to our next generations in safe manner and green like economy we talk about. So these all manufacturing plant having some emissions like carbon dioxide or some gases like H2S and all other poisonous gases are like going into air. So that emissions we need to minimize, and many countries are now enforcing the carbon tax policy, like Singapore already
Yes.
have put into the so we need to minimize those emissions to be more sustainable. So these are the like five very important pillars or enablers for manufacturing operations.
That's really great to hear. Now, I understand that you're currently working in manufacturing, but the whole manufacturing sector started with the Industrial Revolution.
Yes.
The Industrial Revolution that started in Britain in the 18th century, how has that shaped the manufacturing world that it is right now?
Yeah. Okay. So basically, there are different kinds of industrial revolutions. So industry 1.0 we call, which railways or trains run on steam engines. That is the start of real industrial revolutions. Then in industry 2.0, the invention of electricity came, and then electricity was used for mass productions of the goods. So it became more faster, and in industry 1.0 maybe it was more manual things. So using electricity, we make it faster. Then it came recently industry 3.0, where usage of computer and technology for the manufacturing. In that we come across like control systems. So in manufacturing, as I told before, like there is control rooms. So from people sitting in the control room, they can operate the plant simply, like on and off of the pump, which is like maybe hundreds of kilometers away, or opening or closing of the valve. So distributed control systems, SCADA, PLC, all came in that industry 3.0 time. And basically it's like in industry 2.0 those valves were manually operating, so that we do using computer technology remotely, we can do. And this DCS, distributed control system, does not just contain to know the values, but it has like logics inbuilt, so that your plant will run autonomously. Only little manual interventions is required actually. And IoT, nowadays we are calling it as a internet of things, but it is there in the place since industry 3.0. So internet of things is what? So basically simply like in our home, aircon we remotely switch on and switch off,
Yeah.
or in car we have different sensors connected, and it gives on our dashboards, gives different informations. That is basically, or even in outside you see vending machines, that is another applications of IoTs actually. So in terms of industrial area, that is called as industrial internet of things. So basically it is since like 50 years already in place, like all these sensors I talked, temperature sensors, level meters, or many others like flow or pressure meters, all these are basically IIoT sensors. And that can be like there is advancements. Before it was mostly it was like wired connections to controllers. Now in the advancement of technology, we have wireless sensors, and it is very like easy to place on particular asset or equipment and know like vibrations or pressure temperature parameters from that. Even Yokogawa has like sushi sensor, which is well known wireless sensors, which can send data directly from that device to even cloud for further analysis.
Wow.
Yeah. This is about Industry 3.0. Then Industry 4.0, it came more on like advanced solutions. We call it as a like integrated manufacturing operations management. So in that advanced solutions, there are many different kinds of softwares, like starting from planning and scheduling. Like our customers are asking some product or finished good, so that planning and scheduling is done in in that phase, and then it comes to basically different other processes actually. So that is part of Industry 4.0. And even robotics and drones are evolved in this Industry 4.0. And now next step, like we are in between of Industry 4.0 and 5.0. So next is Industry 5.0, where we need to have some cognitive intelligence and to work human with robots, and mostly like we are targeting industrial autonomy, so that a plant can run themselves without human interference. And in addition to that, we have like generative AI and responsible AI also, we need to look into in the Industry 5.0.
Okay. So in Industry 3.0, you talked about all the autonomous processes that take place. Can we call this industrial automation?
Yes, yes. So industrial automation, it started actually in Industrial Revolution 3.0 basically, and that started with the like sensors and actuators. So if you see the ISA 95, ISA is basically international standards of automations, which is like accepted globally. So as per ISA 95 standards, we have like pyramid where level 0 to level 4 we categorize different softwares and applications.
Okay.
So level 0 is basically starting with your physical layers, where all those like assets and equipments and sensors and actuators are placed. So basically, whatever the sensors and actuators which are connected to some equipments, let's say boilers or distillation column or heat exchangers, then it gives all the data like sensing the temperature, pressure, flow, and passing that to level 1. So in level 1, there is something like controllers which are really controlling those particular boilers or valves, like increasing or reducing the temperature. That is done by controllers. Then in level 2, it comes your like PLC, programmable language, programmable controller, or distributed control system, DCS or SCADA, which are like through the control room, basically operators can manage the like production activities, or if any anomaly is there, that also they can control from there. Mostly like programmable logic is there in place, like if this thing happens then you should act like this, like that. Very complex logics are already defined, and it needs minimal interventions from a human being. So that advancement took place in the level 2. Then it comes to level 3 and level 3.5. So level 3.5 is basically a demilitarized zone. So this level 3 and level 3.5 basically contains all advanced applications. So if you see level 0, 1, 2 are very quite important for running your plant in live, like different plant operations. In level 3, it comes like whatever the data you have gathered from sensors, actuators, that will be stored in the like say historian. So all these terminologies like historian, digital twin, are already present in the manufacturing sector since last 15 years, but maybe they are rebranded. So for example, historians is now called as a big data. So
Okay.
basically, in whatever the values time series data are captured from the sensors are getting stored in the historians for long term, and you can identify some pattern out of that data, like pattern analysis can be done. Then in addition to that, there are like something like planning and scheduling. So whatever the demand from the customers can be broken into production plan, and that can be scheduled for different operating parameters in a shift level or day to day level basically. Then it comes, like as I mentioned, like asset management is one of the very critical portion of digital transformation in manufacturing. So using basically this asset management softwares, you can predict the maintenance of that particular equipments or assets well before they fail, and it can avoid your complete like production loss, and you can
Okay.
save billions of the dollars. Then there are like quality systems are used, quality softwares to measure the quality of the software. So all this comes in level 3 and level 3.5 basically. Then there are like something like APC solution, advanced process control, which can contribute to like maximize the productions and lower the energy usage basically. And then there are like to manage the control room operations, there are like operations management softwares. So there are like field operators in the plant. So these field operators are doing some inspection rounds about the health of different equipments actually. So that can be digitized in now digital transformation area. Before it was basically very paper based. They used to write on the paper and come back to control room and then show to the shift supervisor. But instead of that, now they can use mobile apps to record things even from the field using like connected worker applications. They can connect directly to the experts globally, or they can connect to the people in the control room and get the guidance from them. So that is advancements basically. Then whatever the like task or logs they are recording, everything can be digitized in this digital transformation area basically. So that is about level 3.5. So I discuss all from level 0 to level 3.5. These all software applications in manufacturing are called as a operations technology. They are
Okay.
basically lying in plant control network. They are not exposed to outside world or internet. And then it comes to level 4, where all those internet applications or your ERP, enterprise resource planning, or your CMMS system, computerized maintenance management. So maintenance is one of the very important aspect of like this industrial automations, where your assets needs to be maintained. That can be either time based maintenance actually, like every 3 months you should maintain that pump, or using this predictive maintenance, we can come to know before that also, and it will be like condition based maintenance can be done using like your APM solutions along with CMMS solutions basically. So that is basically IT word. This is basically OT. So now we need to integrate them, IT and OT together, and not just at our one plant level. Like some customers, many customers has like different plants geographically located. So enterprise level collaboration is another important things. So in industry 3.0 and 4.0, basically these applications were working very in silo, in unintegrated manner. So using this IMOM, our task is to integrate them together and then create some data lake out of that. So that data lake can be utilized by our AI and machine learning to get some insights out of that.
Okay.
So traditionally what was happening, like people were just for the day to day things on paper based recording the things, but it was used only during that shift, and later there was no correlations of that data. So with this digitalizations, that all data lake can be prepared, and we can get really important recommendations, so that we can be sustainable moving ahead.
Okay. I picked up on a word you used, that was digital twins.
Yeah.
I understand they're a digital replica or a virtual replica. How do digital twins specifically apply to manufacturing?
Okay, okay. So digital twin is not new to manufacturing. Actually, we call in our terms like operator training simulator. Actually, which is
Okay.
creating exact replica, digital replica of the plant. So why do we need this basically? So like there are many like graduate trainees are joining the plant operations as an operator or some other role. So on at very first time they cannot directly work on the operations because it's very like mission critical things, and if something goes wrong, everything can go wrong, and it has much more different impacts in terms of monetary and health and safety.
Of
So
course.
our trainees should be like trained using this digital twin solutions, and they can experience different kinds of like scenarios, like if I do these conditions, what happens digitally instead of experiencing in the field. So that for that reason digital twin is important. And in the advancement of technologies, we are using AR and VR technologies in digital twin. So using smart glasses, they can feel like they are inside the plant, and then they are working on different actual operations digitally. So that is advantage of this digital twin.
Wow, okay. So I guess AI also comes somewhere in between all this. And AI is a very exponentially growing market right now. What trends do you see artificial intelligence and machine learning as well contributing to the field of manufacturing?
Yeah, yeah.
How does it change up the game?
Yes. So as I said, like challenge with manufacturing industry was like no availability of data. So many people call data is new oil actually. So with this industrial automation and industry 4.0, we are trying to digitalize all these things, and I mentioned like data lake we will form. Then now it comes the picture of the AI, where all these data points will be churned by your AI and machine learning to get some recommendations in that. And in addition to that, we are with like robotics and drones. So like robots and drones can be used instead of people in the field. Like best case example of the robots is like there is very remote plant, or where human cannot be stayed, so we can use robots to do the analysis or whatever inspection of the plant. That is one thing. And there are like many fields with some poisonous gas like hydrogen sulfide H2S gas. So there it's very like risky to be human there for operations. Robots can do those operations. Then drones, actually if you see, there are big like emission columns are there in the manufacturing plant. So drones can be used to have to measure the emissions from those like emissions column, or some aerial survey of the plant can be done with the help of drone. So that are some best cases of AI ML. And in addition to that, I feel like this predictive maintenance or visual inspections also, like in many other like industries, people were used to check the quality visually for that. Now with the help of these visual inspection techniques, that can be inspected better, much better than human being actually. So that is, I feel, some best cases of AI and ML in manufacturing.
So AI is also penetrating the manufacturing industry now.
Yes.
Okay, so with more digitalization also comes the greater risk of cybersecurity threats. How can manufacturing firms or the whole manufacturing sector protect themselves from these threats?
Yeah, this is quite important. Maybe you have read in the past, like there are cyber attacks in the refining plants, and then it takes down whole the plant actually, or like there is data theft. So that is the reason this manufacturing industry are very like not pro to move to the cloud and all, where they feel there is cybersecurity issue. But now with advancement of technology, basically we need to go with cybersafe. So not just the plant control network, we need to move all our data points on the cloud for better like leverage all the analytics things from the like Azure or Amazon Web Services, because these guys are also working and in the industrial, like AWS has industrial data fabric. So
Yes.
if we want to leverage, we need to go to the cloud. But for that, definitely like cyber security measures needs to be taken, and all those like encryption of the data when we are moving to the transit in the cloud. So that is one of the very important aspects we need to consider in digital transformation.
Okay. How is Singapore in particular dealing with this digitalization of the manufacturing industry?
Yeah. So like Singapore is called as a like Silicon Valley of Southeast Asia, and very like cutting edge technologies Singapore government wants to implement here. Like recent example is world's first like biometric passportless entry at airports is implemented by Singapore. So like that in manufacturing also, Singapore is trying their best, because manufacturing is one of the key pillar of the economy. Although Singapore is tiny dot and it has very like tiny red dot, it has very like less scope in establishing the plants, but they are the guidance forward for the different technologies in the manufacturing. So Singapore has like Economic Development Board, EDB. It's taking so many measures to have research and development in the field of manufacturing. One of the outcome of that is like SIRI assessment program. So SIRI stands for Smart Industry Readiness Index.
Okay.
So they go to these different manufacturing plants and they assess what is the digital maturity using SIRI framework, and then they recommend what you should do in order to be in line with the age or whatever the moving technology. And if you see different plants, manufacturing plants in the Singapore are with state of art facilities with advanced technologies there. Then recently EDB along with A-Star, they have started some initiative is like AI MFG, AI for manufacturing. So they do different research in that using this AI MFG initiative. Along with that, different universities in Singapore or Polytechnic College are tying up with industries to do research in this particular area. And AI Singapore or Enterprise Singapore, they are quite involved in this research area for manufacturing and AI ML.
Okay. So, what are the challenges the manufacturing sector is facing with this digital transformation?
Yeah, so major challenges with digital transformation in manufacturing is people's mindset, to change the people mindset basically. So people are used to with very like manual jobs or paper based jobs. So instead of that, when we ask them to get transferred on digital technologies, they are reluctant. That is due to like human behavior, and second one, fear of losing the job actually, because they are thinking like if machines will do all the jobs, then where we go. So that is the basic challenge they have. Then another challenge with this AI and ML is like we say data lakes and too many data points are there, but really if that data is not having the sanity, then it will be garbage in garbage out. Whatever the recommendations we are getting from this, if our source of truth is not good or sanity is not there, then it will create problem with recommendations and everything will fail. So for this reason actually we cannot go just a statistical analysis. We need domain expertise in that field, and when domain and statistics marry together, then really we can get something better. Then with digital transformation in the manufacturing, everything is measured with tangible benefits. how much I produce better, what will this digital transformation increase my profitability or not. So basically, there are many intangible benefits with this digital transformations, but persuade that or convince that to the customers is a bit challenging, because they always see value in increase in the productions and profitability. So that is another challenge. And in terms of AI and ML, basically, if you see, the success rate of AI experiments is only like 10%. So 90% projects are failing. So as these manufacturing applications are more business to business, B2B, due to these failures or the intangible benefits, uh, industries are not ready to invest too much as like other industries like fintech or insurance or other sectors. So that is another challenge. And one of the challenge you already highlighted, like cyber security. So everything whatever we are implementing should be cyber safe actually. So these are, I feel these are the basic important challenges with digital transformation.
So we've come to the end of the interview. Is there anything you'd like to add on as we wrap up?
At the end, I would like to emphasize on like why do we need this digital transformations. So basically, we need to leverage the capabilities of computers and AI ML to do whatever done by the machines, and then we need to make people more smarter, and then our assets or equipments work harder, and then our processes should work more efficient to achieve those five pillars of the manufacturing. So basically, health and safety, then productivity, quality, asset reliability, and sustainability. Yeah.
Okay. Thank you so much for your time today. It was a pleasure talking to you.
Yeah. Thank you. Thank you very much.
Thank you to our viewers for tuning in today. Do like and subscribe and comment what other topics you want me to talk about. Thank you.